Welcome to C++ for Java programmers. I'm Professor Caleb. This video series will cover various C++ topics in order to help Java programmers be successful in writing C++ programs. For this first video, I'll be going over some basics. For demonstrations, I'll be using Linux with Visual Code for my editor and G++ as my compiler. Most of what I'm doing should easily translate to other environments. I want to start by talking about the relationship between C++ and Java. C++ and Java are both C-based object-oriented languages, and there are several similarities. The most obvious is the fundamental syntax. Braces, parentheses, square brackets, and semicolons are all used in the same ways. Arithmetic works the same way. The two languages also mostly use the same control structures, so ifs, switches, while loops, for loops, do-while loops all work pretty much the same. So I won't focus on those things here, because I assume you already know them. However, we do have some differences between the two languages. This list is by no means exhaustive, but it can give you a starting point in understanding what we're going to look at in this series. C++ is much less insistent on object orientation. You can write C++ programs without ever using a class. You always write at least one function outside a class because main can't be in a class. C++ very much supports object orientation, but the philosophy is different. Input and output are going to be quite different. Some things about functions are the same, but there are some significant differences that we'll need to be aware of. Scoping is similar to Java, but again, there are important differences that we'll need to understand. Arrays are a big topic. They are very different in C++ in ways that can easily cause errors for the inexperienced, or even for the experienced, so we'll spend some time there. The libraries provided by the two languages are quite different in ways that are both good and bad. We'll look at some of those. The way the two languages handle dynamic memory is completely different. C++ trusts you and expects you to do the hard work of managing the memory you use. So that will be an important topic that we'll cover in multiple videos. There are also quite a few differences in the way C++ does classes compared to Java. So we'll have quite a bit to look at there as well. Now that you have some idea of the big picture, let's start with some basics. We'll begin by writing the traditional Hello World program. So to do that, we're going to edit a file named hello.cpp using code. I encourage you to follow along. No better way to learn or review programming than to actually do it. Let's blow that up just a little bit more. Make sure it's easy to read. Okay, so the first thing we always need is some comments at the top of our file. We're going to begin by indicating what the file name is. The reason we make a point of doing that in C++ is there's no expectation as to what the file name is going to be in C++, the way there is in Java. So Java forces you to name your file based on the name of the class it contains. C++, whether you have a class or not, you name the file anything you want to. So it is traditional, sort of standard to include information about what's this file at the top of the file. Of course, we should always have a description of what's in our file, so we'll just indicate that this is the traditional Hello World program. And then, of course, you always want to say who wrote the code. Make sure you own whatever you do as far as any programs you write. I've chosen to use single-line comments here. We do also have the standard multi-line comments. JavaDoc, of course, is not a thing in C++, though there are comparable kinds of systems available. Okay, so now we have our opening comment. Let's move on to the actual code. We want to write something out. So in C++, that's going to require accessing the library that lets us do that, which happens to be called IOStream. So the way we do that is we have pound include, and then inside angle brackets, the name of the library, as I said, IOStream. As we talk about this include thing a little more, I want to note that this is copying a file. So somewhere there is a file on your system that has the information needed to allow you to use the IOStream library. That file is literally going to be copied into your file at this point. So that's something that's very different between Java and C++, is just how they handle this. The other thing we want to do here is to make sure we have access to the things in IOStream. So those are in something called a namespace. We have two different ways that we can access them. One is to, every time we want to use one of the special names from the IOStream library, we can put the namespace : in front of it. But a more convenient way, and something that I tend to do most of the time, is to just declare that I'm using that namespace. That does mean that I can't use any of the names from that namespace myself, because I can't be in conflict with any of those names. So I'm going to say using namespace standard. STD is how standard is spelled in this particular case. And now we're ready to actually write the program. So let's write main, which looks like int main. And then we have the information for the command line arguments. So in Java, of course, that's simply providing an array of strings. In C++, that's a little more complicated because arrays don't know how big they are. So we have to first say, here's how many arguments I have. And then we have an array of those actual arguments. Now, one thing that's interesting to note in C++ is that you don't actually have to include that. So in Java, you have to include the array of arguments. In main, you can actually leave that out and just have empty parentheses for your main. So in C++, you can leave that out and just have empty parentheses for your main. So now let's actually write our output line. That looks like this. We have cout, which is the name for standard output in C++. And then we have something called the insertion operator. That is what allows us to actually write to the stream. It's one of several options, but it's one of the most common ways to do output. And then we'll have hello world. And we'll go ahead and put our \n in there so that it doesn't look funny. And that's all there's going to be to it. So strings, again, double quotes for strings, single quotes for characters, just like it is in Java. So that's similar. Now that we've written this, let's go ahead and save it. And then we'll come back over here and compile it. So I'm compiling using G++, which is as simple as saying G++ hello.cpp. If I look here, I've got my hello.cpp. The executable is in this thing called a.out. That is the default that compilers will do with C++. It's kind of weird, but it's the way it is. To actually run that, we're going to say /a.out in Linux. And so if we run it, we see the hello world. Now, I want to note one of the reasons why we want to make sure we include our \n by leaving it out for a second. This is why you always want to include the new line at the end of your program. If I recompile this and run it, you'll notice that I get the hello world, but then it immediately does the prompt afterwards because I didn't do a new line. Nobody's going to throw an extra new line in there for you. You should put it in yourself. I do, so let's actually fix that because it will bother me if I don't. So I do want to show you how to compile with a specific name for the program. So I'm going to name this program hello, and So this says G++. This is a dash small lowercase o for output file. Then we have the name of the output file, which will just be hello. And then, of course, what we're compiling. And so if we take a look, we see that we've got the a.out still, but we've now got hello as another option. And if I run hello, it's going to complain because I forgot my dot slash. But if I run it with the dot slash, you can see it runs. And of course, we had put our \n back in. So it runs nicely. Okay. So let's come back over and talk a little bit more about input and output. First of all, just the names of things. The standard input stream, so the equivalent to system.in is cn, and as I just showed you, the equivalent to system.out in Java, the standard output stream, is cout. We have these two operators that are used sort of standardly for doing a lot of our input and output. The insertion operator, which is two less than signs, is writing to an output stream. So whatever we pass into it, whatever's on the right-hand side, will get written out to the stream that it's pointing at. Then we have an extraction operator, which reads in data. And that looks like two greater than signs, as you can see. And what goes on the right-hand side of it will be the variables we're going to store the data into. A good way for keeping these straight and remembering which one is input and which one is output is just remembering that it's pointing in the direction the data is moving. So the input stream or output stream is always first, and then if we're printing to it, we're going to be using the operator that points at the stream from the data we're printing. If we're extracting things from it, if we're reading from the stream, because it's an input stream, then it's going to be pointing away from the stream toward the variables the data is going into. Okay, one more thing I want to comment on is the \n versus an alternative, which is called endl. That is a lowercase l, not a 1. So endl. This is an alternative to new lines. And there are times when we really want to do that. The reason has to do with how input and output is managed in computer programs. When we transfer data in and out of a program, it doesn't typically work character by character or even word by word. Instead, we're going to transfer the data in chunks. How big those chunks are is dependent on specifics of the computer architecture, but typically it's going to be at least half a K, so 512 bytes. The reason we do it this way rather than sending a few things at a time is efficiency. The computer is set up to write that much in one operation. So it would be silly for us to use lots and lots of these write operations in order to get data that we could write in one operation to the screen or to the file. Input and output are expensive compared to what we do inside the computer and its memory. So as we write data to the screen or to a file, it doesn't write it directly there. Instead, we go to something called an output buffer, or we read into something called an input buffer. So here's what an output buffer might look like in concept. It's just an array of data. And we build up things character by character in that output buffer, and then we write out the whole chunk at once. You've actually probably seen this in action in early programs where you used files. At least once you may have forgotten to close your output file after you wrote to it. So then after you ran your program, you opened up the file, it was empty. The problem wasn't that you hadn't written the data to the file. The problem was that the data you wrote to the file went into the output buffer and you hadn't written enough to fill up the output buffer and get it written to the file. Now, when we close the file, the computer writes everything that's left in the output buffer to the file before actually closing it. But if you didn't close the file, that didn't happen. By the way, the term for that thing about writing what's left in there is called flushing the buffer. So you flush the data out of the buffer to wherever it's supposed to be going. Now the difference between a \n and endl is endl forces a flush of the output buffer, but \n does not. In many cases, we don't want to force a flush because it does make our output less efficient. However, there are a number of places where we may want to. For example, if our program is crashing and we're adding print statements to help us figure out where the problem is occurring, we need an endl at the end of each of those print statements in order to make sure that our debugging output actually gets all the way to the screen or file before the crash. Otherwise, we may end up thinking that the crash occurs earlier than it really does because we see that these things didn't display to the screen. Well, if they didn't have an endl, they might have been printed, but only to the output buffer. Let's go ahead and write a simple program that uses some input and output. We'll come back over here, and actually what I'm going to do is just modify this program to actually have some input and output. So do something very simple, just set up an age variable. Then I'm going to ask the user for their age, and then we'll read that in to the age variable, and then we'll write that back out. Okay, so let's come back over here and compile that again. We'll go ahead and compile it into the hello and then run it. Did I not save it? I bet I didn't save it. That's a little better. So let's be very obvious here. And it comes back and says that. So let's look at what we did. Of course, we wrote that's the same as what we did with Hello World. Then from standard input, we used the extraction operator to get the age that the user put in, and then we can write it out. Now it's worth noting you can string several of these together. So this actually returns a string that can be used by this operator to write out the age. That returns a string which can be used by this operator to write out the endl. You can also actually do that same kind of stringing together with extraction operators, but obviously in most cases that's not a good idea if you're doing user interaction, because you always want to ask for each individual piece of data before you read it in. Now, of course, if the user thinks of it as one piece of data, but we're treating it like multiple pieces of data, we may do that. And from files, it's very common to do something along these lines. Okay, now that we've just seen a basic bit of input and output and variables, let's go ahead and talk about data types in C++. These are mostly similar to Java. So you'll see int, short, long, float, double, and char, or char if you prefer. But there are some important differences. A first thing to notice is that short and long are actually modifiers in C++, as opposed to separate types. You can use just short in a variable declaration, but the type is technically short int. Same goes for long and long int. Also note that there's actually a long long int, which can be abbreviated long long, and there's also a long double. The precise size of ints, shorts, longs, long longs, and long double varies among implementations. The language standard only specifies a minimum length for the integer types, which is 2 bytes for both the short and the int, 4 bytes for a long, and 8 bytes for a long long. On 64-bit architectures, the short is 2 bytes. The int is typically 4 bytes, The long varies between 4 and 8 bytes, and the long is, of course, 8 bytes. The real lesson here is don't count on the size of your integers being predictable in C++ if you're not writing for a specific architecture. Ints are still sometimes 16 bytes, or 16 bits, 2 bytes, on 32-bit architectures. If you don't know for sure what's going to be the case, don't count on a specific size. Note that you can use the size of operator to determine the size of any type, including an int. Another difference between C++ and Java is that integers and char can be signed or unsigned in C++. Signed is the default, which would be the same as Java, though you can specify that something is signed if you choose to do so. To make a variable unsigned, you simply put the word unsigned in front of the rest of the type name. This is used in a variety of places where we know we don't need to support negative numbers, and we would like the extra positive range. Note the difference in range for a signed versus an unsigned 4-byte integer. So for signed, we have negative 2,147,483,648 to 2,147,483,647. Whereas the unsigned version is going to start at 0 and go up to 4,294,967,295. So we have that double length on the positive side. Another difference between C++ and Java has to do with characters. The char type in C++ is just 1 byte, so it only covers ASCII. There actually is a wchar_t that is provided for wider character types, such as Unicode. It's worth noting that in C++, a char is treated in a lot of ways as if it were just another integer type. There is no byte type in C++. We typically use char in places where we might use byte in Java. There are 2 other elementary types we should mention. The Boolean type in C++ is bool, and then void is actually considered a type, mostly used in relation to pointer variables. One thing that is important to recognize about Boolean expressions in C++ is that they don't have to be of type bool. An if or loop condition can be any value. If that value is 0, then the condition is false. If it is literally any other value, the condition is true. This can be quite useful on occasions, as we'll see in dealing with pointers, but can also cause quite a bit of grief. A number of errors that Java will catch for you as compile time errors become logic errors in C++, and errors that can be pretty hard to track down at times. Let's look at some examples. If 3 less than a less than 8. We know we can't do this. It should be 3 is less than a and a is less than 8. But if we actually write this, it will work and it will be true, because what happens is it does the 3 is less than a. The result of that is going to be either 0 if a is not more than 3, or 1 if a is more than 3. No matter what, 0 or 1 is going to be less than 8, so this is always going to be true. If a is assigned 9, now you've done this probably, but in Java it's a compile time error because you can't have an integer in an if. It has to be a Boolean value. But here you can have it. This is just true because a is assigned 9 returns 9, the value 9, and that's not 0. Similarly, if we have c is assigned 0, presumably you meant c equals 0, this will always be false because c is assigned 0 will return 0, which is the false value. And if we have if a is assigned b, we meant a equals b, but made that mistake. It will be true as long as b is not 0. They'll both be that value, and false otherwise. If b is 0, they'll both be 0, and what the assignment returns is 0, so it's always false. These are things that would be errors in Java. Here, they're errors, but they're logic errors and they can be hard to find. So you want to be very aware of this issue in C++. The last topic I'd like to mention in this video is named constants. In C++, these work much as they do in Java, with two important differences. First, the keyword we use is const, short for constant, so that's pretty straightforward. The other is that the value must be given to the constant at the time it is declared. In Java, we can postpone that assignment, though we can only assign into a final once. In C++, that doesn't work. Thanks for watching this tour of some of the fundamentals of C++. In the next video, I'll be talking about C++ functions.